All right, guys. So now we're going to talk about a few questions from 48. Specifically, we're going to talk about 3, 4, and 5. And then I'm going to jump over to 48.5 and probably do 2 and 3. All right. So, again, always make sure you try these. I know this is a different concept for you, but eventually you're going to see questions in the AP exam you have never seen before, right? So make sure you try. All right. So, number 3. Okay, says a rectangle is bounded by the x-axis and the semicircle that you see there. What length and width should the rectangle have so it can have a maximum area? Now, to have the maximum area, okay, that right there, let me make this a little bit bigger. To have a maximum area, you need to figure out the formula. Now, it even tells you that the formula is A is length times width. Okay, so we can say the A is length times width. So let me go over here and then write the formula. So we can say that A is the length. Now, the length in this case is going to be, since this is x right here, well, this little part right here should also be x. Okay, so the length is going to be 2x. And make sure you write small on this because it's going to take me it's going to take me a little bit of room, okay? And then at the height, or the width, the width is basically the distance from here to here. Now, this point right here, which is the height, is given to me by the y coordinate. And the y coordinate, remember, is this. All right, so this is the y coordinate. So that the width for this specific problem is going to be the square root of 25 minus x squared. Now, unlike other problems that I've shown you in the past, there's no need for me to go much further than this because everything has the same variable, right? Everything is in terms of x. So I can go ahead and remember the steps. I need to find a formula that relates what I'm talking about to maximize or minimize. And then I need to take the derivative of that formula and set the derivative of the formula equal to 0 and solve for x in this case. Okay, so I'm going to take the derivative of area with respect to x. I'm going to call this dA dx. And I'm going to do the product rule. So I have the first times the derivative of the second. Now the derivative of that, I'm going to use a chain rule. All right, so all of that I just wrote is just the derivative of the square root of 25 minus x squared. Now, I'm going to add, let's see, the second, which is the square root of 25 minus x squared, times the derivative of 2x, which is 2. All right, so this part is at least a little bit easier. Now, I'm going to have to do some simplification here because this is pretty ugly. Okay, so I can say that this 2, well, let me change colors here. This 2 right here is going to cancel with this 2, and I'm going to end up with a negative 2x squared, it looks like. Let's see what else. All over the square root of 25 minus x squared. Okay. And then on this side, I have a 2 square roots of 25 minus x squared. So I don't really have to do too much work. Now, but what I do need to do, and now I don't really have to do this, but it will make my problem easier, is I'm going to find a common denominator. Because remember, I have to set this equal to 0, right? So I'm going to find myself a common denominator so I can just set one single fraction equal to 0. And I can just set the numerator equal to it. But let me just one step at a time here. So what I'm going to do is I'm going to multiply. Here, let me see. Let me erase that real quick. I'm going to multiply top and bottom here by 25 minus x squared. And again, I'm trying to find a common denominator so I can add these two fractions together, or these two quantities together, I suppose. And yep, okay. So it's going to give me a negative 2x squared over here still. This is going to give me a 2 times 25, which is 50. Well, when I multiply those two square roots, the square roots go away, and I end up just with 2 times 25 minus x squared. So I have minus 2x squared all over my common denominator of 25 minus x squared. Now, I can add like terms, and notice that these two are alike. So this is going to be negative 4x squared plus 50 all over my denominator. Now, when I set this equal to 0, I can put this as 0 over 1. Right, so essentially what I'm going to try to solve for is negative 4x squared plus 50, if I cross multiply in the previous step, equal to 0. So this is what I have to solve for. Okay, so now I'm going to solve for that. Let's see, if I subtract 50 and divide by 4, I would end up with x squared is equal to 50 over 4. And I can take the square root of each side. So my answer in this case would be plus or minus the square root of 50 over 4. Now the square root of 4 on the bottom would be 2. Now 50, if I take the square root of that, well, that's the same thing as 25 and 2. So this is 5 and 5. So this is going to be 5 squared roots of 2. Okay. So let's see, what are the dimensions? What am I looking for here? What are the length and width? Okay, so it looks like I found, well, x, almost found the width, not quite. Now, remember, the width is 2x, right? So to go back to this, the length, is 2x. So twice as much as that is going to be 5 square roots of 2. Yeah, sorry, I'm looking at my previous answer here. So now let's keep it in red here. Length is equal to 2x, which is now going to be equal to 2 times 5 square roots of 2 over 2, which is going to be 5 square roots of 2. Let me check my answer here before I go too far to make sure we have the same thing. Okay, so that wrote the length as 10 over the square root of 2. So let me see if that is equivalent. So I know the answer that I gave you was not what I just wrote there, but I just want to show you that it is going to end up being the same. So that's going to give you 5 square roots of 2. All right, so we're correct on that. So now for the width, all I have to do now is I have to plug in the same thing that I just found here, and I have to plug it in here and figure out what that is, right? So I'm going to write that over here because I'm out of room here. So the width is going to be 25 minus x squared. Now that's going to be, now here's the deal, guys. Well, I don't know what you want to put. You can also put x squared is equal to 50 over 4 if you could see that far ahead. But so this is 5 squared, so 2 over 2 squared. And I'm just going to have to try to solve that. Now when I square, let's see, on the bottom I definitely have a 4. And when I square the 5, that's going to give me 25. And if I square the square root of 2, that's going to give me 2. So that's going to be 50. If I use a common denominator, 25 is the same thing as 100 over 4. So this is going to leave me with 50 over 4. So again, if you don't see how I did that, please, for the love of God, just add 25 minus 50 over 4 on your own. So that's going to leave me with, again, pretty much the same thing. 5 squared roots of 2 over 2. And let's check that answer that I gave you. Okay, they wrote that as 5 over the square root of 2, which is the same thing. Okay, so again, the answer that I gave you was 5 over the square root of 2. And if I were to try to get rid of the square root of 2 to simplify this, I would have 5 squared roots of 2 over 2. So yeah, we're good. So this is one answer. This is the length. Excuse me, that's the width. And this is the length. Okay, so that's it for that problem. Well, let's move on to this one. So I don't think I'm going to do the whole thing for you because you have a very similar problem in your homework. And if I do all 3 problems here and then I do another 2 over here, I mean, you barely have anything to do yourself. Okay, so here's the deal. And I'm going to show you where this is different. It says a rancher has 200 feet of fencing with which to enclose 2 adjacent rectangular corrals. What dimensions should be used so that enclosed area will be a maximum, right? So notice that it says the word maximum in here. So I want the area to be maximum. So what I'm going to do here is first, I'm going to write the area formula, right? And the area formula is just, again, length times width. The length in this case is going to be 2x, and the width is going to be y, okay? Now, the difference on this problem is that I want to have everything in terms of x, so I can take the derivative of the array formula and set that derivative equal to 0. Okay, so they give me other piece of information here that says that the fencing is 200 feet total. So if I have 4x, notice that I have x, and I would have x here and x here, right? So that's 4x. And then if you add all the vertical sides, that would be 3y. So when I add those together, you get 200. So what I'm going to get from this formula is I'm going to solve for y. And it's not necessarily it's not going to be a pretty equation. And then I'm going to divide this by 3, divide this by 3. Now, of course, you could divide the entire thing by 3. But I'm doing this for a purpose. And hopefully you see what the purpose is in just a second. So now I have 2x times 200 over 3 minus 4/3 x. I'm going to distribute that 2x, so that's going to give me 400 x over 3, and this right here is going to be 8 over 3x squared. Okay, so I'm going to now take the derivative of that and set my derivative equal to 0. Now the derivative of this right here is just going to be 400 over 3 because the derivative of x is just 1. Okay, so in this case, we're going to call this dA dx for fun. And then derivative of this right here, remember this is 8 over 3 is just a constant. So you just take the derivative of x squared and then multiply that times 8/3. So that's going to be 16 over 3 x. Okay, so hopefully not too terrible. And then now what I'm going to do is I'm going to go ahead and take the derivative of this. Excuse me, I'm going to set my derivative equal to 0. And then solve for x. So I'm going to start off by subtracting 400 over 3. And then I'm going to multiply both sides now times, say, negative 3 over 16, which is going to cancel all of this. So let's see this. I'm going to cancel. It's going to give me a positive 400 over 16, which if I reduce, let's see, that would give me 100 over 4. I feel like something went terribly wrong here, but I can't tell. So I guess that's going to be, oh, that's 25. I'm just an idiot. So that's going to be 25 for x. Okay, so now if that's 25 for x, let's see, what dimension is the use of the close to maximum? Okay, so I found the x, but remember the area enclosed is going to have to be 2x, all right? So the area enclosed is going to have to be 2 times 25, which is 50. And then now I'm going to really use this formula now to figure out what y is going to be equal to. Okay, so I'm going to plug in, I'm going to write it on here because I don't have any more room here. I'm going to plug in a 50 for x. Excuse me, a 25 for x. Whoops, I almost messed that up. So again, I'm plugging this in. And then I'm going to solve for it. So we have 100 here. This is 3y. This is 200. So it's 3y is equal to 100. So y is equal to 100 over 3. Okay, so my final answer should be that the dimensions of the maximum area enclosed should be 50 feet by 100 over 3 feet. Okay, so I believe that's it for that one. All right, so let's go on to this last one. So this last one is definitely one of those you can definitely do without a calculator, without really doing any math because you can see the picture, right? But it's a good problem just to kind of prove to yourself that this stuff hopefully makes sense. It says a rectangle is bounded by the x and y axis, and the graph of y is equal to negative 1/2 x plus 3. So here's the figure. You can see it. So what length and width should the rectangle have so that the area is maximum? Remember, it has to be enclosed between the x and y axis and this curve right here. Okay? So one more time, I have to figure out the area of a rectangle. Now the area of a rectangle is going to be length times width. Now the length, in my case, all right, now I know that you can literally count 3 here, but let's not do that, right? We're just going to say we don't know. We're going to call that x. And now the height is going to be the y-coordinate. Okay, it's going to be the y-coordinate. And this y-coordinate totally is depending on this formula. So we're going to call this negative 1/2 x plus 3. And then now we're going to distribute. And the nice thing about a problem like this is by the time we distribute, we have all the same signs or the same variable, excuse me. So I'm just going to grab that, take the derivative, set my derivative equal to 0, and then solve. Okay, so let's take the derivative with respect to x. So this would be negative x plus 3. That's the derivative. We're going to set that equal to 0. So x is equal to 3. Okay, so there it is. And you can literally count it. 1, 2, 3, right? And then now we're going to plug in this 3 to figure out the height. We're going to plug in this 3 into this formula right here, the one that we had at the beginning, right? Because the height is given to me by precisely this formula. So we're going to plug in that 3 in here, right? So let's see, that's going to give me a negative 3 over 2 plus 3. And remember, 3 is the same thing as 6 over 2. So this is going to be 3 over 2. Okay, so my dimensions should be 3 should be 3 by 1.5 or 3/2, which is the same thing. Okay, so let's go ahead and just quickly go over to 48.5. See if I have it pulled up here. All right, so let's do 48.5. And I believe I was asked about questions. Okay, I was asked about a question. Let's see. Let me make this a little thicker again. Let's see. 2 and 3. Okay, so question number 2 is basically the same thing as question number 3 on 48. Okay, so I'm trying to think whether I actually want to do this or not. So here's the deal. I will not do 48.5 yet. Okay, because I want you to do number 2 because it's the same idea. I'll even draw you the picture if that'll help. So a semicircle of radius 3. Oh, and I can see why that you probably have problems with that. You're trying to fit a rectangle in here. And we're going to call this X. And this point would be X, comma, Y. Okay? Now, what I'm going to do, however, is I'm going to, and this is the part that probably most of you don't remember, how to write the equation of a semicircle of radius 3. Okay, and that would actually be this. Positive 9 minus x squared. Okay, so remember, to find the area, right, we want to have the largest area. So the area is going to be equal to the width, or let's call this area length times width. I'm trying to look at the last one just to keep it the same for you, so to avoid confusion. Let me see. Yeah, length times width. So the length, we're going to call it a 2x, and the width is going to be the square root of 9 minus x squared. Okay, so I'm going to leave it there for you, and I want you to see if you can get the answer. Now, let me see, 48.5, and let me write you the answer in 2 ways so you'll recognize it. I believe they say that the width for this one, I don't really like the way the person did the key, which was not me, puts this, but they call this the width, and the length, they call it 3 over the square root of 2, or really you can write this as 3 square roots of 2 over 2. So either one, right? So see if you can get there. And let's see, the other question that was most commonly asked was the next one, which is very similar to the other problem that I did there, right? So again, I don't want to rob you. Maybe once I do this, maybe let me draw you a picture maybe, and you can go from there. Okay, so if you have 350 feet of fencing, will be used to enclose two adjacent rectangular pens. It's not a big deal. It's just like this. Okay, one should be enclosed in the area. Okay. So what we can do, and this is not the only way to do it now, because it says it's 2 pens, or at 2 adjacent pens, we're going to call this x and this y. Now, if this is x, this is also going to be x, okay? And now we want to find the dimensions that should be used, so the enclosed area would be maximum. So it's basically the same problem as the one that I did in 48, okay? So And let's see, tell me the amount of fencing. Yes. Okay, so it's literally the same problem, guys. I don't know what to tell you. So make sure to do that on your own now, right? Because I'm not gonna do that one for you. And again, by the time you get the answer, one side should be 175 over 4. And then the other side is going to be 175 over 3. Okay, so try it out. Again, I know it's probably not the easiest, but I don't necessarily want to do the same problem twice, all right? Because I want you to learn how to do it. All right, if you have any more questions, guys, please let me know. And let's see if we can get this homework done tonight.